Alright, so this video is going to be over numbers 4, 5, and 6 in our quadratic book. So the first thing that I want you to remember is we talked about this is a max vertex. We also talked about our scale. So this was at 30. This was at 2.5. So we could very well then count 1, 2, 3, 4, 5 because a ball will always start on the ground at the origin. So it's going to land 1, 2, 3, 4, 5 at 5 seconds. And we said our parabola would look something sort of like this. So based on the information provided, the point where the ball was kicked, we already did that. We did that at 0, 0. And when will it hit the ground? That point was at 5, 0. So trace the path of the ball. We already did that. Blank depends on blank. Remember, this is always y depends on x. So this is going to be height depends on seconds. So then we went ahead and we talked about, we had 3 points here. We have 0, 0. We have 2.530. And then we also had 5, 0. And we talked about for this piece we needed to go to our calculator, and we could use our calculator to write our regression. So we went to list and spreadsheets, and we had x and y. We had 0, 2.5, and we had 5 for our x's, and then we had 0, 30, and 0 for our y. We went to C1, menu for 1. This was quadratic, so we used number 6. We changed this to x and y and hit enter twice. So we got our quadratic regression. Oh, I apologize, hit a button. And we said that y is equal to negative 4.8 x squared plus 24x. So then for 4.5 seconds we know is x. So we said you could do this a couple of different ways. Because this did add to our graph, we can go to our graph and put our quadratic. We talked about using our table, and we could change our table to have a table skip of 0.5. So we could in fact then see that at 4.5 it was at 10.8. Now something else we could do is on our graphing calculator, we could say negative 4.8, which was again our A value. And if we're saying x is 4.5, then we could say times 4.5 plus 24 times 4.5, and we will, oh, I forgot my squared again, I apologize. It's supposed to be 4.5 squared. And then we get 10.8 as well. So we could say y is 10.8, and this was feet. Using your graphing calculator, determine when the ball was above 20. So again, we're going to go back to our table, and I can see here at 1 second, we're almost to 20. And then at 4 seconds, we're just below 20. So we need to write this as an inequality. So at 4 and at 1, so we could say just less than x less than y, or less than 1 is less than x is less than 4, because our y is 20. And at 1, we were at 19.2, so we weren't quite there yet. And at 4, we were also at 19.2, which is why does a ball appear twice at this height? Because what goes up must come down. Okay, so we don't want to put equal signs underneath our inequalities there. The domain of our situation, if we drew our window as we practiced way back in the first semester, we can see that in fact it is continuous. So we need to say 0 is less than or equal to x is less than or equal to 5, and the range is 0 is less than or equal to y is less than or equal to 30. Where will the ball be at 6.5 seconds? Well, 6.5 seconds is way over on this far side, so it will be on the ground because it landed at 5 seconds. So unless it fell into a hole, we should be good to go there. On number 5, we talked about we have some coordinates here. So we can say +3, -1. We can say 4, 0, and 5, -1 is our buddy point. We have our axis of symmetry. We have one root, and our root happens to also be our max vertex. So when we go down here, we can look at our root 0 x-intercept solution is going to be 4, 0, as well as our max vertex is also 4, 0. So usually when you have one root, your vertex will be the same. Our equation for our axis of symmetry is x equals 4. We have buddy points at 3, -1, and 5, -1. Our y-intercept we'll get to because we can't actually see that. We have a max value. Remember, the max value is your y, highest y value, which in this case is 0. And we have a concavity. That's how is it opening. It is concave down. And remember, if it is concave down, that means your a is going to be negative. Our range, if I was to draw, now I do not have arrows, but we're going to assume that it's going to keep going, is going to be -∞, and our highest is going to be 0. And it does touch. So y is less than or equal to 0. So now we're going to look at our quadratic regression and vertex factored and in standard form. So we can very easily start with our vertex form because we have hk. Now we talked about our parent function, which is always going to be over 1 up 1, over 1 up 1. So if we are looking here, now we're going over 1 and down 1. So that means that in fact our a is -1, because if it's going up and it's over 1 up 1 is a +1. So our a is -1. So when I come down here to my factored form, remember that y is equal to a times x minus h quantity squared plus k. So now I have an a of -1, x. My vertex, remember, is my hk. So my h is 4, so -4 quantity squared. I have a k of 0, so I'm not actually going to write that. I can go straight to my factored form because I know that x minus 4 squared looks like x minus 4 times x minus 4. And then to do my quadratic, I need to actually multiply that through. So I'm going to go up here and I'm going to FOIL so that I can have -1, and then we have x times x is x squared, x times -4 is -4x, -4x, -4 times -4 is a +16. Can collect like terms. This is going to be a -8x. So now I have y equals, when I distribute my negative, it changes all my signs, -x squared plus 8x minus 16. And that tells me right here, this is my c, so I can go back and I can write down that my y-intercept is 0, -16. Now I can compare this to my parent function, and based on my hk, I can say that it does in fact go right for, it doesn't go up or down any, but when I look at this negative, that causes us to have a reflection across the x-axis. Okay. The next one we're going to look at is in fact number 6. Let me see if I can find that one. And I'm thinking it is possibly this one. 6 was right here next to 5. I just simply missed it. Sorry about that. So again, so now we're going to have to graph what we are being given. So we can make a couple of notes. We have some buddy points. We have a vertex. We'll decide if it's a max or a min in just a minute. And we have a root here. So if I count -7, 1, 2, 3, 4, 5, 6, -7, 0 is here, -6, +3, -5, +4, and then I'm coming back down, -4, +3, and I can see that I do in fact have a line of symmetry. My A is going to be -1, and here this is 1, 2 away, so I'm going to say here's my other root, which happens to be at -3, 0. You can also now see that this is a max vertex. Because we have a table, this is going to be discrete because we do not have any situation to say that it's continuing to be connected. So our roots are -3, 0 and -7, 0. Our axis of symmetry that we just drew was x equals -5, and our vertex, which was a maximum, is at -5, +4. We have buddy points at -6, 3 and -4, 3. We don't have a y-intercept yet, but we do have a max value of 4. We already talked about it's discrete. Our range is going to be a list because it is discrete. So we're simply going to list our y values, -5, 0, 3, 4, 3. I'm not going to go ahead and list the 0 because I added that extra one. I can go ahead, we already talked about our A, so we can do vertex form, y equals -1x. Remember we have our hk here. -5 becomes a +5 squared plus 4. And then we can take that and go to our quadratic regression, but I'm going to go ahead and compare it to my parent function first. So I know that this is in fact going to go left 5, up 4, and reflect over the x-axis. You may need to use your journal for this quadratic regression. I'm not sure why I did that. We're going to go ahead and multiply it out. So we have x plus 5 quantity squared plus 4. So I'm going to say x plus 5 times x plus 5, which is in fact x squared plus 10x plus 25. I'm going to go ahead and add my 4, my parentheses, and my -1. So I need to distribute by order of operations. I've done my exponent first. Now I'm multiplying. So -x squared minus 10x minus 25 plus 4. That 4 does not change because it is not within the parentheses. I can collect like terms. So my quadratic is -x squared minus 10x, -25, and a +4 is a -21. So if I want to do my factored form, now I can do my cross puzzle. Let me see if I can move this a little bit so I have some more space. So now I'm going to do my cross puzzle, but before I do that, I am actually going to factor out this negative. So I'm going to take out a -1 so that, actually no, we don't have to do that. We'll just leave it. I'm going to write A is -1, B is -10, and C is -21. So A times C and -1 times -20 times -1 is +21. C is -10. So I know both of these need to be negative. A negative times a negative is in fact a positive. So -7 times -3 is a +21, and -7 and a -3 is a -10. So now I can go ahead and do my grouping. So I had -1x squared minus 7x minus 3x minus 21. I'm going to group these. I'm going to